Hello, let's continue our Sudoku adventure with Opabina by Jean. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have killer cages in the grid. Some of them have clues, some don't. But in all killer cages, digits can't repeat. And so if I were to put a 1 here, I can't also put a 1 here. Sudoku would allow it, but the cage does not. All right. And when the cage does have a clue, the digits in the cage sum to the value in the top left. So these three sum to 7, these two sum to 9. Could be like 3, 6. That sums to 9. All right. In addition to that, we have these red lines in the grid. These are parity lines. Digits along a parity line alternate between even and odd. So for example, if this was a 1, that's odd. The next one has to be even. A 2, a 4, a 6, doesn't matter. And then the next one has to be odd, maybe a 3. And the next one needs to be even. Next one needs to be odd. It could be a 1 again, right? Just keep changing parity. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay. I think coloring might be in order. So we don't know whether this starts even or odd, but we know it alternates. So coloring how it alternates can often be helpful. And then we can figure out if it's even or odd later. And in fact, we might be able to figure it out right now. Because a 7 cage, there's only one way to add to it. 1 plus 2 plus 4. And so there is no other way without repeating digits to add to 7. And so we know the remaining digits here are 3, 5, 6. Now you'll notice that that has 2 odds and an even. And that means that green has to be odd and purple has to be even in order for that to match up. And so that actually places the 6 here. And this is only 2, 4. All right, this is 2, 4 as well. So this has the other orange on it. We don't know which one is orange, but it has the other one. And so that means that these two have to be even, and that gives us the odd and the even here. This digit doesn't go here. I wonder if that's important right now. It goes to one of these two. Do we know any more here? The 9 cage. So we know that a 9 cage is, because it's an odd sum in 2 digits, it has to have 1 even and 1 odd in it. And that's true here as well. So these nines use up one of the odds. This is another odd. So we get one more odd. So this row gets one more odd. This column gets one more odd. And that kind of... I think that means this has to be a 1, but I'm trying to justify that. Like my head's telling me that it has to be the odd digit. So my thinking is this 7 cage has 2 evens and an odd. And so, I don't think that's true. Like my thought was, okay, that means that if this row needs one more odd, this column needs one more odd. Does that mean that it has to be at the intersection? Because this 7L shape here has 2 evens and 1 odd. It can't have multiple odds. But I think we could do an odd here and then an odd here, and that would still work. We'd have 3 odds in this row, 3 odds in this column. So, okay, so my initial instinct wasn't quite there, but there may be something to that. It feels important. We know there's 2 odds and an even down here. I don't see how that helps right now. So geometrically, whatever this cell is, it can't repeat in any of these. And so it's one of these two, but I don't know what to do with that information. I guess I could write it to the 9s that they're either 3, 6, or 4, 5. They don't have 1 or 2 in them. So if this was 4, 5, this would be a 4, and this would be 3, 6. If this was 3, 6, this would be a 5, but... So if either of these are 4, 5, it forces the other one to not be 4, 5. So they're either both 3, 6 or one of them is 3, 6. So the fact that we need at least one 3, 6 in these, does that matter? For some reason. I'm not seeing it. Okay, so piece of information we have these even odd ones here. These are the same parity as each other. Does that matter? Yeah, they can't be blue because we know that the 9 cage needs an even and an odd. I was thinking about how that affected the rows and columns, so it affects this box greatly. These especially because these two are the same. These two are the same because of this line, right? And so they can't be even because now we don't have an even for the 9 cage. So they have to be odd. And then this is the final even for the box, which is a 2 or a 4. And that means this is even. So we have 2 evens up here. Right, so if there's 2, yeah, this is odd. So there's 2 evens and an odd up here. And these are different. So this is 1 even, 1 odd, which means this has to be the other even. That makes this odd and this even. All right, I think I just missed some roping deductions earlier. We know that we need an odd, which is going to go there. So this is the 3 or the 5, making this the 4 or the 6, and even. This is the last even for the row, so these are both odd, and this is even for the box. We know 1 is in one of these two, because it's not here. This is the 3 or the 5. So do we know how this works out? These two are the same. They can't be even because we already have 2 evens. We can't have 4 of them. So these are both odd. That's even, and this is even. All right, so this is not this. This is this because we can't repeat in the box. So that means that the other even is a 2-4 right here, making a 2-4 pair. But this is even. So this is the 4 or 6, and then this is the odd 3 or 5. That makes a 3-5 pair. 2-4 pair here means this can't be 2 or 4. So it's either odd or it's the 6. Oh, but it's not 3. It's not 3-5. It's not 2-4. So it's 1 or 6 only. That's interesting. 2 evens, 2 odds. What am I doing here? I'm almost fully colored. Okay, we need an odd and an even here. And we need an odd and an even here. And then... oh, the odds are done in this column. So these are both even. So that has to be the 2-4 pair. And that place is the one where I said we could get away with not doing it in the corner. Anyway, I'm glad I saw that. That's a 6. That's even. That's a 4, 2, and 4. We get the 2 and 4 here. We get the 6, which adds to 9 with a 3. The 4 adds to 9 with a 5. Nice, 3 in the corner. So this is a 1-5 pair. This is a 3-5 pair. This is 5. This is 3. This is 3. We get a 1 and a 5 here. So yeah, this is odd. So this is even, and this is odd. Okay, we're colored. This is a 1-3 pair. Yeah, this has to be the 5. This is the 3. 4 means that's 4, because it can't repeat in the box. That's 2. And so this is a 2-6 pair, and this is a 2-6 pair. So this has to be the 4, yep, for the box. That's a 1. You can kind of solve the evens and odds separately now that the cages are resolved. They should be basically 2 separate Sudokus. So why don't we focus on the evens? Yeah, so this is a 4. This is 2-6 pair, but the 6 says that's 2, that's 6. What's going to resolve these 2 6s, though? Good question. They feel unresolvable, but we'll see. Maybe I'm missing how that works. So we'll do the odds then. This is 1-3-5. That's not a 3. This is, oh, this is the 1-3-1, 5-3-1. The 5 here, the 5 here, the 1 here. And what am I missing that resolves these 2 6s? Is there a clue? Oh, this killer can't repeat. Right. So we can't repeat the 6. Okay, yeah, that's why this killer pulls up there. All right, that's 2-6. That's 2-6. I knew there had to be something, or I was wrong. But both solutions seemed correct. But until I realized we had this cage. All right, cool. Well, neat puzzle, Gene. I enjoyed that as usual. Took a second to like figure out how the coloring propagated, but there was some clever use of cage non-repeats and some roping arguments and stuff like that. Very neat. Well, how'd you do?